So we just had the transformations quiz, and we've already done lessons on everything, the translations, reflections, and rotations. But I did, as part of the quick review before the quiz, and I think maybe even for some classes at the end of the day, I had sort of maybe done a different type of lesson on rotations. So it was actually a much quicker one, and it's really just a shortcut method, which I don't love shortcuts, but it will work. There's really no reason why it shouldn't work. And I can't think of a reason why I shouldn't just teach you the shortcut for this particular lesson. So I'm going to go ahead and do the shortcut for you. So it would be for a problem where you are doing a rotation of a triangle. Really quickly, though, I want to point out if you see a problem on reflections, this would also be sort of the process you could do, only you would do a reflection at the end instead of a rotation. The first part of it, I guess, is what you would repeat, which is just being able to draw the graph out on your own when you're not given a graph. So, for example, in both these problems, you aren't given a graph. You're not given a X and Y axis with a picture on it, with an image on it. So you need to know how to create it yourself. So with these particular problems, I'm going to show you how I would create the graph, and then how, for rotations, how I would just do the rotations, or how I think you should do the rotations, really. And I'm not going to do the review of reflections across these three things, which I did this in a different video. So if you want to go watch, it's in the video from, it's either October 6th or October 7th. I think it's October 6th. But I did a review of reflections where X equals a number, so something like that, or Y equals a number, something like that. And then there were two other situations which we hadn't done at all, Y equals X or Y equals negative X or something like that. It could be X equals Y, you could flip the sides. So I reviewed those on October 6th if you want to watch that, if you missed that particular lesson for some reason. That. So when you get a problem and it says rotate, yeah, there we go. Rotate the triangle. I'm probably going to have to change my zoom. So let's do that first. So let's see. That's not too bad, I don't think. It's actually easier for you with paper and pencil than it is for me on this. So I'm going to go extend it just a little bit more even. All right, so now I want to have it right at the top, the problem. All right, so you get a problem, there's no graph. There are other ways to do it. There are formulas you can memorize, but there's probably at least 6 formulas that you would have to memorize between just rotations and reflections, and that doesn't even count translations. So I don't like the memorizing formulas part. So what I would suggest you do is that you draw your own graph, and then you do the rotation thing that we talked about with the graph itself. And this is only for around the origin. Shoot, I didn't type this in here. This is only for around the origin. So rotating around the origin. Around the origin. This does not work if it's rotating about some other point. So I'm going to get rid of this. You can always come back to it if you need to see what I just wrote here. Oh, my screen's not working real well. I got some other stuff going on in the background, so hopefully I can record this okay. I'll have to go back and check it then. So anyway, we'll get rid of that. So the first step is to draw your own graph. I would make it as big as a full sheet of paper. The bigger, the better. It needs to have enough hash marks, and hash marks are just the numbers on the number line. So you don't know, this is the x-axis down here. This is the y-axis down there. I'm going to actually remove the x and y. I think for rotations, it's actually confusing if you have x and y there. So I'm going to get rid of those two things. And I'm also not going to write the numbers on my number lines. I'm just going to put the hash marks. So, whoops, there. Oh, yeah, again, my computer screen is really slow right now. This stuff going. Hopefully this will work okay. So I'm going to say, all right, well, there's one hash mark, 2, 3. You want to make them as close as you can to the exact distance apart. Like they should be, the space between each set of hash marks should be the same. So that the little miniature line segment should be the same. So how can I explain that? I mean, basically it's representing 1, 2, 3, 4, 5, 6 going up. But make sure you make them all the same. Like don't put 2 really close together and then 1 far apart and close together and far apart. You cannot do that. They have to be the exact distance apart, as close as you can get it without probably a ruler, because I don't think they're going to give you a ruler or anything like that. So now I do the same thing on the bottom. There's one, as long as you can see them. Again, it's really hard for me to write right now on my screen. So I'm just doing my best with it. It's going to be easier for you, I think, than it is for me. So see, I'm getting these a little too far apart, I think, but you'll see it's still fine. They'll still work. Just do, oh, that was way too far. I am going to move that back. That was, So these hash marks are just representing 1, 2. So these right here would be 1, 2, 3, 4, 5, 6 for the x-axis. Then the ones to the left of that would be -1, -2, -3. The ones going up from the origin would be your y-axis, 1, 2, 3, 4, 5. The ones going down would be -1, 2, 3, 4, 5 for your y-axis. All right, so now I just plot all of the points on the graph. So 1, 5 would be up here. 2, 1 would be right here. And this is the part you need to really be careful on, making sure you're lining up the points correctly with the hash marks. And then 4, 3 would be 1, 2, 3, 4, 1, 2, 3. So very carefully put these dots on. That's the crucial part. Now you can draw the image. You don't even really need to connect it with lines. I'm going to change colors just to try to draw the line there. So there is my original, or my pre-image, really is what this is called. Oh, and you would want to label the points X, and then which one was Y? This is Y down here, and then this is Z. Make sure you label them X, Y, and Z, or whatever the points are. Now, so you would have this drawn on your paper. And here's the part that's actually a little easier, probably for you even. Yeah, perfect. So I have to use the magic of technology to do one thing real quick. There we go. So once you have your image, it's telling you to rotate it some direction. 180 degrees would mean it would be in this area over. Oh, that didn't work. Oh boy. Oh, shoot. What happened? Don't know what just happened. Yeah, gummit. I don't know why I just did that. I think I'm still okay. Let me do what I did before. Try this again. I don't know why it undid what it. There, that's what I need to be able to do. Okay, so it looks like it's okay. Actually, tell you what, let me. I'm gonna scroll. Now that we have the. Oh, actually, here, I'll zoom out. Now that I've drawn it, I can zoom out. If it'll let me. There we go. That should be a little better. All right. All right, so there is the problem again. So I've drawn my picture on my graph. This is the pre-image, the original points that they gave me. Now, using your paper, and again, this is only for when it is around the origin. You just need to rotate your entire piece of paper however many times you should turn it. If it's a 90-degree turn, we said that is 1 quadrant. And then the direction just depends on whether it's clockwise or counterclockwise. So you can look at a clock and use your finger to circle your finger in the correct direction. But clockwise would mean this figure would go down one quadrant. That would be clockwise. Clockwise is this way, like that. That's clockwise. You'll see when I spin it even better. 90 degrees means only one quadrant. So I'm going to be moving this down into the lower right quadrant, quadrant 4. So you would take your paper and just turn your paper one time. That is where your new image will wind up being. Now, the reason I think it's easier to not write the numbers on is because a lot of students are getting confused trying to look at the way the numbers are showing up once you turn the image. You don't change the X and the Y axis. You got to think of the X and Y axis as staying still. This is still the X axis over here. This is still the X axis going left and right. So that is still the X axis. And the Y axis is still this one going up and down. If you write the numbers on there, then it gets confusing, and sometimes you have you choose the wrong number. So that's why I don't write the numbers. Two things. So you just want to think of this as still the X axis going left and right, just like a normal X axis, the Y axis going up and down. The positive numbers for the X are to the right, positive numbers for Y are going up, negative numbers for left or X are going left, negative numbers for Y are going down. So I'm just going to choose the new coordinates based on where this image is, now that I've rotated it one time. So for example, my new X prime, would be at 1, 2, 3, 4. Boy, that's not right. I put it on the wrong points. Dadgummit. All right, I'm going to fix it real quick. Shoot, my fault. I did not count. I made a mistake, and I just put it on the highest point. I didn't. There we go. We'll see what I mean in a second. Actually, I'm going to erase all of this, and I'm going to do it over again so I have it in the correct spot. So again, I've drawn my graph. I accidentally put the points in the wrong spot. If I would have counted, I would have seen 1, 5 is actually 1, 2, 3, 4, 5. It's actually right here. I went all the way to 6 instead of only to 5. So now 2, 1 was correct. That one was in the right spot. That one didn't change. And 4, 2, 3, 4, 1, 2, 3 is there. So I'm going to go back to, actually, I'll go to fly for this. And I need to label them, so that's X, Y, and now I can rotate the image. Nope, now I got to do this. Group it again, since I had to redraw it. So now I can rotate the image once. These are my new points. Again, the X-axis is just a normal left and right X-axis. Y is just a normal up and down X-axis. So my X prime, wrong button, is exactly where that X point is in my new image. So it's at 5, -1. My Y prime is exactly where this point is for Y, which is at 1, -2. And my Z prime is exactly where the Z is down there at the bottom. It is at 1, 2, 3, -1, 2, 3, -4. So 3, -4. And that is my new set of points, my new image. If it tells you to draw the image, then you could flip your paper back over. Actually, you just put those points on your paper on the computer screen. You just plot those 3 points right there on the screen, and it'll be in the correct places. So that's pretty easy. Oh, one more thing I'll tell you. There should be a pattern for every single new ordered pair. So for example, going from my original X, let's see, highlighter, yeah. Going from my original X right here to my new X, if you notice, I switched the position of the X and Y, right? So now the first number is the 5 and the second number is a 1. But in the original point, the 1 was positive. In this new point, it is negative. So the sign of the first number that is now the second number also flips. You can't think of it as making it negative. You have to think of it as flipping because it depends on where it starts. And you'll see that happens for everything. My new Y point, so we'll do that in a different color. This is Y. The new Y, again, the order flips. So now the 2 is second, the 1 is first. But again, the 2 is now the opposite sign. It's in this case, that's a negative, but you can't think of it as them becoming negative. It's the opposite sign. Let's see. And then for my Z, again, the numbers flipped, and the first number now has the opposite sign. The 4 is now negative. So that's quick version. I'll post this and it'll be on YouTube. And then, like I said, if you want to look at reflections, that was the October 6th video.